Okay, here we go. We're on to 4.2. So this is going to be a little review, and I'm looking out at empty desks. I'm in my room and there's nobody in here. So I'm teaching to nobody right now. So hold on, I'll be back Monday. I know, for some of you that's very upsetting. All right, so continue. From what I understand so far, you guys have been doing good. Continue to do that. Or Monday, I come back and we'll have the hammer. All right, first thing I need to do, I got to get my absolute value all by itself. So I'm going to subtract 6 to both sides. Oh, I didn't say this, but you should have already done the warm-ups. That's kind of a procedure thing. So I have the absolute value of 4x equals 22 minus 6 is, no one's going to say anything, so I'll just say it, 16. So then I go 4x equals 16, and 4x equals negative 16. Remember I set it equal to the positive and negative answer, so I divide by 4. X equals 4, x equals negative 4. This is where you start wanting to do a shortcut. You're like, oh, I just get the one and then I make the other one the other side. No, that's not how it works. Please don't do that. So here, I'm going to have 3x is less than 30, and I'm going to have 3x is greater than negative 30. Now, if you don't know how I got that, you're going to have to come in for help. Or go to the PACE lab. Yes, go to the PACE lab. X is less than 10. X is greater than negative 10. Those are your two answers. Okay, here we go. All right, we are going to graph absolute values. And the first thing you're going to do is you're going to graph the parent function. Functions move away from their parent function through a series of transformations or shifts. Up, down, left, right. So, we need to know what the parent function is. The parent function of the family of absolute value functions is y equals x. This is the parent function. So, when x is negative 2, I have y equals the absolute value of negative 2, so that's positive 2. Y equals the absolute value of negative 1, that's positive 1. Now, please, I understand that this is a little difficult because I'm teaching and there's nobody in the room. And now you're just listening. It's like you're at the movie theaters watching a movie that's really boring and you're eating your popcorn and you're going to fall asleep. You got to pay attention. You got to follow along. The absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So now we get a parent function. This is the function. Anytime you have an absolute value, this is what the graph looks like. When it's the absolute value of just x, it looks like this. So, negative 2, I go to negative 2, is at positive 2. Negative 1 is at positive 1. 0 is at 0. 1 is at 1. And 2 is at 2. So as you can see, when you have an absolute value, you have a v, and the origin, I'm sorry, not the origin, I just spaced on what that is. It's been a busy day. The vertex is at the origin, all right? So whenever you see the absolute value of x, you don't have to do this. You can just come over here and just go to the origin, put your vertex right there, put a dot there, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Draw your lines. There you go. So you now don't have to fill out this table. So let's go to the next one. Okay, so what does this sign right here? Whoa, scary, spooky. What does this do to our graph? Well, I can show you if you want to graph it. I mean, we can. The opposite, this is the opposite of the absolute value of negative 2. Well, the absolute value of negative 2 is 2, but then do the opposite, so that's negative 2. So now I have negative 2, negative 2. Whoa! Negative 1 is going to be at negative 1. 0 is still going to be at 0. 1 is going to be at negative 1 because it is the opposite of the absolute value of 1. The absolute value of 1 is 1, but then you have to do the opposite right here. You get negative 1, so you're going to get negative 2. So you're going to have 1 at negative 1, 2 at negative 2. What happened? What happened here? Well, it got inverted. See, when you did the absolute value of x, if I'm graphing y equals the absolute value of x, I do this. Oh, I put my dot here, like it should be. Then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I go in both directions, and then I make my v, right? So that negative sign inverted. It flipped it over the x-axis. All I did was I flipped this. Instead of going up, I went down. So you have to memorize that this negative sign out here flips. How did the graph change from the parent function? Inverted or flipped over the x-axis. It's inverted. That sign out there inverts it, flips it. We can graph easily by using the parent function and shifting. So, here's what you need to remember. Write the vertex, that's the dot, maximum or minimum. Change the sign with the x. Graph the positive slope to the right, the negative slope to the left. We'll explain that later. Don't worry about it. Here's what you need to remember. If a number is with your x, it lies. Just like you. When you're with your x, you lie. Oh. Okay, just like you. When you're with your ex, you lie. Did you know that girl before we broke up? No, baby. I never seen that girl before. Yeah, you lie. So if it's with the ex, it lies. If it's by itself, it tells the truth. With your x moves you right or left. You want to write these arrows. By itself moves you up or down. So we know our parent function, our vertex is right here at 0, 0. Well, now we're going to move our vertex based on the shortcuts I just gave you. With the x lies, so that means I'm not going to go to negative 2, I'm going to go to positive 2. So I go over 2, and then I'm going to go up 4. 1, 2, 3, 4, and I put my dot right there. There's my vertex now. And then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Boom! Easy peasy lemon squeezy. That is where I put it now. Instead of putting it at 0, 0, I use my clues. With my x lies, and that goes right or left. By itself tells the truth. That goes up and down. You need to memorize that. It'll make this so much easier. You have to memorize, though, that your original parent function vertex is right here at 0, 0. Okay? So, here we go. Uh-oh. What happens when I have a half? What the heck keeps happening? Okay, so now the question becomes, what does this 1/2 out here do? Well, it's going to cut it in half. So let's look at this. Is there anything with my x? Well, the answer is no. There's nothing with my x. See, there's nothing inside of my x, so I don't move right or left. I do have a number outside of my x. That's going to move me down 3. So my vertex is now at 0, 3. Okay? Let's look over at number 5 real quick. Is there anything with my x? Yes, it's negative 1. So it's with my x, so it lies, so I'm going to move over to positive 1. There's nothing outside my x, so there's where my vertex is going to be on number 5. Okay, now let's deal with the half. Usually we go up 1 over 1, right? Well, this time we're going to go up a half over 1. 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 Okay? So what does this do? It spreads it out. It makes it wider. And then I make my arrows. So when you have a half out here, it makes it wider. You don't go up 1 over 1. You go up a half over 1. This one is very simple. I went 1 to the right, and then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Boom. Everything comes off of the parent function. Now, my vertex, is my vertex a maximum or a minimum? Well, it goes up from here, so it's a minimum. Same thing over here, it's a minimum. If it's inverted, then it would be a maximum. And my vertex is at 0, 3, right here, 0, 3. Here, my vertex is at 1, 0. See, you go x first. It's over at 1 on the x. Didn't go up or down any. Okay. Okay, now if you remember, with absolute values, you have to shade. So, with my x, it lies, so I went over 1. I made my v, now I have to shade. So here's what I'm going to do. I'm going to test a value. I'm going to test a value inside. So I'm going to go to -1, +1. So my y is +1, is less than the absolute value. My x is -1, -1 plus 1. So is 1 less than the absolute value of 0? Is 1 less than 0? Is 1 less than 0? Is 1 smaller than 0? No. So we have to shade outside. You pick a point inside the cone, inside the V. If it's true, then you shade inside. If it's false, you shade outside. Let's go ahead and look at number 7. And guys, I understand this is very confusing. This will be posted on YouTube. When I get back, you can come in and ask any questions you want. You can also go to Khan Academy. You can look up graphing inequalities at Khan Academy. Anyways, let's look at this one. Do I have anything with my x? No. But I do have a +1 that's away from my x. So nothing's with my x, so I stay at the origin, and then I go up 1 on the y-axis. Remember, this right here is up because it's +1. So then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Oh, there's something I forgot over here. See how that's or equal to? That means my lines are solid. This one is not or equal to. What does that mean? That means my lines are dashed. So I have to make these lines dashed. All right? Now that's something you should have remembered, and I didn't, so there you go. So hey, okay, now we're going to test the point. We're going to test x is 0, 1, 2, 3. Y is 3. So is 3 greater than the absolute value of 0 plus 1? Is 3 greater than 0 plus 1? 0 plus 1 is 1. Is 3 bigger than 1? Yes, so I shade inside. I know that gets confusing. I'm going to post this on YouTube, or on my YouTube channel, so you can go back and rewatch it if you want. Or, you know what? Go to the PACE Lab. If you got questions, go to the PACE Lab. Okay. Now, I'm going to go over these two again. With my x, it lies. So I have to go to -1, 2, 3, 4. Then I go up 1, because that is by itself. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I make my v. I'm done. Now, this does have a minimum, because see, your vertex is down here at a minimum. And my vertex is at 1, 2, 3, 4. -4, comma, 1. I have to use my ordered pair for my vertex. Okay? All right. Now, you can figure out number 9 by making an XY table. Okay? But if you're going to multiply it by 3, what's that going to do to your absolute value? It's going to triple it. So this is going to be, it's going to go up very steep. Use the XY table to figure that one out. Again, we have our vertexes. Negative 1/2. What does that negative sign do? That's right, it inverts it. Oh boy. Axis of symmetry. A line of symmetry for a graph. The two sides of the graph on either side of the axis of symmetry look like they're mirror images. So your vertex is your axis of symmetry. Right here, my vertex is at 2. Cuts the graph in half, which means this side is the same as this side. So I write it x equals 2. That's my axis of symmetry. What is my axis of symmetry? Well, that is at -2, so x equals -2. What is the coordinate? This is going to be a maximum, so your vertex is above, and the coordinate, it's a maximum, and the coordinate is at -2, 3. What are the coordinates of the x-intercepts? Here's an x-intercept, and here's an x-intercept. So I am at -1, 0, because y is always 0 at your x-intercepts. And I am at -5, 0. Why did I say -1? That's +1. Good catch. Front row. Must be in the front row. Okay, we've already talked about all of these things in class. We're just kind of putting it together now. Okay. What's the domain and the range of the graph? We've already talked about this. Your domain is which? Your x or your y? That's right. Your domain is your x. So your domain equals, your domain is domain right here. I'm going to go from, what am I going from? I'm going from -2 to infinity. Because this is going to start at -2 on the x, and it's going to keep going this way forever and ever. So my domain is -2 to infinity. All right? My range is right here. It's at +3, and it's going to go from +3 to infinity. All right? What is the rate of change? This is slope. -6, I'm over here now. -6, 1, 2, 3, 4, 5, 6. So right here is -6. Remember, these are brackets. That means these are your x1, your x2. So 1, 2, 3, 4, 5, 6. This is my ordered pair. -6 is with -1, right? Now, you don't need to calculate, y2 minus y1, because I'm talking about this ray right here. This ray right here. All right? So this ray right here, from left to right, it's increasing. It goes up from left to right. So the rate of change, we already know it's 1/1. I told you that. So your rate of change here, your m equals 1/1 or 1, because it's on this ray. It's on this ray right here. This ray right here. Your rate of change is increasing. -1, that's your x1, -1, 2. So that means I'm talking about this ray. This ray is decreasing. It's going down from left to right. So that means my rate of change is -1/1. See, this ray right here that I'm erasing, you just got to figure out which ray you're on. Your rate of change for these is 99% of the time going to be 1/1. You just got to figure out, am I talking about the positive ray or the negative ray? Compare and contrast the rate of change. They're the same, because remember, rate of change, the negatives don't matter. What is my axis of symmetry? -1, -2, -3, -4, -5. My x equals -5. That's my axis of symmetry. What is the coordinate of, this is going to be a minimum, because that's my vertex. The coordinate for my vertex is -5, -2. That's my x and my y. Coordinates for the x-intercepts are right here. Remember, y is 0 at the x-intercepts. Those are all the same. This is all the same. All right, kids, be good. Love ya. Have a nice day. Do your worksheets. Bye-bye.